So what is the purpose of linear regression or regression? To predict a dollar value, right? Where you have, okay, a number, not dollar value, but any number for that matter. So let's say if I have, I need to predict, okay, the one that I think I have is, you want to predict, let's say, marks, okay? You want
Okay,
to predict
let's do,
marks.
okay. Sales, for instance, sales for, I have sales for 2022. I
Yeah, yeah,
want
you
to.
can do the same concept. Let's first focus on concept first, okay?
Oh,
Then you can relate it to the question you have.
mhm.
So see, so you have marks, right? And now on what factors marks can depend. Okay. So
Okay.
marks will depend on, and in simple linear, okay, the way we call it simple is because there is only one factor that impacts.
Mhm.
Okay. And of course, your problem will not be simple. Problem will be multiple, right? But to start from somewhere, right? You have to start, right? So that's why we're starting with simple linear regression. So
Mhm.
marks, let's say, is dependent on number of hours you study.
Yeah.
Okay, number of hours you study. Now there are few terms that you need to understand. Okay, one is, okay, when you look at x, okay, x is supposed to be input. Okay, x is input, and you have y is supposed to be your output.
Output.
So generally we represent y as output and x as input, right? So in this
Okay.
case, what is input and what is output?
Input is your previous marks, I think. Output is your
Why
predicted
will
mark.
I see output means why should I want to know how many hours you study? No. See, our intention is to find marks, isn't it? Our
Marks.
intention is not
Yeah.
to find. So output is marks, right?
Marks.
How
Yeah.
much
Input is
marks you
also
study?
marks.
Yes. So marks would be your output, and study will be your input. Okay.
Okay.
Something which is under our control. Okay. Something which is under our control is
Mhm.
input, and something which is not in our control. Okay. But we want to control it. The intention is, see, if marks was in our control, we would, we would is get as many marks as we want.
Okay.
Fact is that marks is not our control. Okay. But there are indirect ways to control marks, right? What are
Mhm.
indirect ways? For example, the sales you're saying, there is no, see, every if if sales was under your control, everybody would make billions of sales, right?
Yes.
But thing is, you don't have sales under control. Your customers will come and buy from you. So what you can make is you can make product better. You can sell it lower price. You can make product better. You can give after sales the benefit. So those are the factors you'll provide so that you are selling more. Why do we buy, let's say, a particular phone? Why do people buy iPhone, right? Because they see value, right? So the Apple's aim is not to increase sales. Apple aim is to make things which will make people buy. Just
Mhm.
because you are the you are you're it is possible, right? Sometimes putting a high price itself is is a feature, right? Not everybody can demand, right? I can't make a product and price higher than iPhone, right?
Mhm.
So there is certain factors which will help iPhone to sell more, and for that matter anything that you buy, right? So you buy things for the value that it gives to you. People buy.
Mhm.
So what we're talking about these days is how to provide value to your customer. If you provide value to your customer will buy from you. Okay. So that's why. So what we are doing is we can't control the cells, but we can indirectly control the cells by these factors. So we want to figure out what are the factors which impact sales. Okay. So we'll start with, as I said, with one dimensional simple problem, assuming that, okay, number of hours you study will impact the mark. Okay.
Mhm.
Now, since we're talking about supervised learning, you will have past data, right? So what will do,
Mhm.
you will go and interview the people who have already, let's say, have given the exam and passed, right? So if you're talking about a certain grade exam, So you will go and you already speak to the seniors who have already gone through it.
Mhm.
You'll ask the senior saying, okay, tell me how many marks you how many hours you studied and how much marks did you get. So
Mhm.
you will go and you will get some data. Okay. So you get, let's say, 3 hours you studied and got 28 marks. Studied for 4 hours and got 39,
40.
right?
Okay.
Whatever, right? So
Yeah.
so you're going and you're getting this data. Now,
Mhm.
what we need to do is we need to plot our XY axis. Okay. So on X axis, okay, you have study. Something which is in our control, we generally put it on X axis. And
And
see,
in any input.
yes, input is under control, right?
Yeah. Yeah.
Input is under control. Number of hours is in your control, right? How many hours you practice is in your hand, right? But output is not in your hand.
Yeah.
So we are trying to look. So these are called input or also called as features.
Mhm.
They are also called as features, right? And in this example, particular example, I'm talking about only one feature. But yeah, I told you you can have multiple features. Okay. So you have x-axis and you have y-axis. Now you take the data and you start plotting the scatter plot first.
Mhm.
Okay. So see, for every visualization, for every data problem, you need to first visualize them, right? And that
Yeah.
visualization will be part of every kind of algorithm. So here
Mhm.
you are visualizing using scatter plot. Okay, when you talk about two numbers, scatter plot is the plot that we need to have. Okay,
Okay.
so x hours is also number and marks that you obtained is also number. So you take xy and you start plotting. So let's say 3 hours is 28 marks. You get this. Okay,
Mhm.
4 hours 40 you get this. Okay. So let's say you end up getting something like this. Okay. So what it shows is if you look at the data, okay, it shows that there is a positive correlation between X and Y. And we discussed what is positive correlation, isn't it? If X increases, Y also
Y
increases,
also increases.
right? So if X increases, Y also increases, that's called positive correlation.
Mhm.
Now, to perform regression, okay, there has to be some correlation. Okay, it has to be either positive or negative correlation. It can be negative also. For example, let's say number of hours you watch Facebook, number of hours you spend on Facebook versus marks you obtain. Hopefully
Will
that will be a
decrease.
negative
Yeah. Yeah.
correlation.
Then.
More
Mhm.
you watch, less marks you will get, right?
Yeah.
So that is going to be your uh, what do you say, negative correlation. But as long as there is a correlation, as long as there is a relationship between x and y, okay,
Mhm.
we can use regression. So here there is a relationship between x and y, so we will use regression. Now, what is regression? Is regression algorithm is all about finding, okay, a best fit line. Okay, it's about finding best fit line which can represent all these data set. Okay, is about best fit line. Now, I'm talking about best fit line because in linear regression you can only get line. But when you talk about SVM and decision tree, we get curve, we can get multiple lines. Okay, so we'll see there when we talk about them. Right now we're focusing only on linear regression. So linear
Okay.
regression, you get this line. This line, okay, is called best fit line. Best fit line is a line that can represent all this data set. Okay. Now, which line is best fit line? Right? In this situation, you can draw many lines. You can draw, from this point itself, you can draw so many lines, right? This can be
Yeah.
another line, you know, this can be another line. Why won't you do this one? You can even do it from here also, you can have a line, right? So you
Yes.
can have multiple line which can claim to represent all these values.
Mhm.
Okay. But we talk about best fit line. Best fit line means the error between, okay, or the distance between point and the line is minimum. Okay, so let's say if you take this red line itself, okay, so let's say this line is there, right? For every line, you're drawing a this is how you measure the distance between line and the point.
Mm-hmm.
Line and the point. Line and the point. Okay, you're measuring this. You're measuring this.
Mm-hmm.
Okay, and let's say if you measure all this, you get 100. Let's say 78 unit. Okay, whatever. Okay. Now, if you draw another line, let's say
Mm-hmm.
you have another line. Let's say like this. So this might have total distance of let's say 150. Okay, so one that has minimum distance.
Mm-hmm.
So that's the job of linear regression algorithm to find a line that will best fit the model or best fit the line.
So if we have like say hundreds of points, so
You'll have thousands of points, why would hundreds of points?
yeah.
Yes.
So we have to find a line where the distance from every other point is minimum.
So you'll have infinite number of lines. The
Mm-hmm.
line that we choose is the one that will have the minimum possible distance between all the points of that line.
Okay.
Okay. Now I'm talking about just one x. Okay.
Okay.
One x, one y. Now let's assume there is one more x. Okay. There is one more x. So this is the study number of hours. Let's
Mm-hmm.
say time spent on Facebook. Time spent on Facebook. Okay. Now to represent that, you will have third dimension,
Mm-hmm.
right? So this is one x dimension, y dimension. You have z dimension.
Mm-hmm.
If you have one more, then you'll have in four dimensions. So imagine four dimension problem. Okay, if you have one more, it will be five dimension. The dimension increases with increase in, that's what we call it dimension. Okay, dimension increases with increase in number of x input parameter. Y will always be one, right? We are always talking about
Yeah.
one thing, but it will be impacted by multiple values. Okay, so more the dimension, more complex your algorithm will become, and slower, of course, it will become slower also.
Mm-hmm.
So later we'll see that we also try to what we call as reduce the dimension as much as possible.
Mm-hmm.
Okay, if you reduce the dimension, okay, let's say instead of you're using six, you have six what do you call features, but out of six features you figure out two are not relevant, two are not that important. So with five or with four rather, your performance will be faster compared to doing six, isn't it? Because six is becoming six dimension, it becomes a lot more uh, complex, right?
Mm-hmm.
So there is a one set of study which talks about dimension reductionality. How do we reduce the dimension? How do we make sure that we go with as less dimension as possible? Now, dimension reducing dimension doesn't mean you are compromising on the output. Okay,
Mm-hmm.
okay. Uh, so generally, what we're trying to do is you have this 80-20 rule, right? That if you put 20% of effort, okay, 80% of work will be done. But to do the um, uh, rest of the 20% of work, you have to put 80% of effort, isn't it?
Mm-hmm.
So that way, okay, you do only 20% of effort, you're still getting 80% of the result, right? And then
Mm-hmm.
you use your time for something else. So that's what we're going to do. Later we'll talk about later, towards the end, we'll talk about how to reduce the dimension. Okay. See, every dimension you reduce, it is going to have some impact. But some dimensions are very important, which will have 90% impact, 70% impact, 50% impact. Some dimensions are not at all important. It might have 2% impact, 5% impact, 6% impact. So if you remove this 2%, 5% impact dimension, your speed will increase. It will be much faster,
Okay.
right? So,
But
so
how do we determine like, which
yeah, yeah, yeah. Hold on.
factors to consider?
We'll do. Step by step, we'll do. Okay. So yes. So determining how many features are important is also job of your machine learning, right? So I told you these are all part of your pre-processing step. Okay, we need, because dimension goes into model building. Okay, so you need to decide before model is built. Okay, so we will spend some time on that as well, how to figure out. Okay, so now coming back to this one here, as I said, here we have only only one dimension, right? I mean, it is two dimension, only one feature and one output variable. Okay, so when you find the line, okay, regression line, this line will have two factors. One is the intercept factor, okay, how much height it is from the origin, and then you have slope factor. Slope is actually defined as change in y minus change in x. Delta y by delta x, right? Change in y. So this is y-axis, isn't it? So now if you see here, probably this looks exactly the same, right? So let's say 5 by 5. So 5 by 5 means 1. So when your slope is 45 degree, okay, it is actually 1. Okay,
Mm-hmm.
slope is 1. As you increase, let's say if it was not here, it was more than, okay, more than, let's say, if this was somewhere here, right? More than 45 degree. Okay. Now in this case, if you see, now if I take delta y by delta y is big, delta x is small. So if you see
Small.
here, the slope is greater than y, 1, correct?
One,
Because
yes.
I mean, you don't have to measure, you can see here, this line is obviously longer than this line, right? Now, if you have a slope line which is less than 45 degree, okay, now if I draw a y-axis, you see, this is longer than this,
Mm-hmm.
right? So, okay, uh, just to give you a understanding that, at 45 degree, okay, your slope is one where change in y is same as change in x. As you go towards y, as you move towards y, your
Mm-hmm.
slope will increase. As you move towards y, your slope will increase. As you move towards x, your slope will decrease. So if you are on x-axis, your slope is 0. If you are in y-axis, the slope is like infinity. Okay.
Mm-hmm.
So slope is going to increase as you go towards y. Okay, as you go towards x-axis, slope is going to go down. Now, why is slope so important? Okay, slope is important because this tells you how much time, okay, or how. So y is your marks, right? So on top, numerator will be y, delta y is change in marks by change
Mm-hmm.
in study hours. Now, if this is greater, that means if it is greater than 1, that means
It's
small
not
change in
restricted.
study hours
Uh-huh.
will result in larger change in
Other,
marks.
yeah.
Okay. So if you even study for, let's say, 10 minutes more, the impact on marks will be even higher. You'll get probably 5 marks more, 10 marks more. If you study 5 minutes less, you will probably lose 10 marks. But if the slope was lower, okay, that means your x is greater than y, right? So
It
x is
doesn't
greater than y. So if you do so much of effort, you're going to get so much
marks are less marks.
less marks, right? So your sensitivity, okay, increases with increase in slope. The sensitivity increases with increase in slope. The sensitivity decreases. Sensitivity means if you change the x little bit, how much impact it will have? It will have very little or very high, right? So if you change like 5 unit, is it output and y will be 2 unit or 10 unit? If it is 2 unit, you say it's less sensitive, okay, and the axis is the your regression line is closer to x-axis. But with
Uh,
little change, if you get more output, okay, that
can you
means
just repeat
your
the
regression line
last
is
point
closer
again?
to y-axis. Sorry.
Sure. Can you like repeat the last point again?
Yeah. So I'm saying if slope is less, it is less sensitive. If slope is less, it becomes your problem statement is less sensitive. That means with small change in x, probably you'll get smaller change in y.
Why? Okay.
Right? If I study for 1 hour, probably you get one, 1 mark. But if
Mm-hmm.
the slope is high, with small change in x, you get more change in y. That means
Okay.
if you study for 1 hour, you'll probably might get 12 hours, 12 marks, not 1 mark, 12 marks,
Mm-hmm.
right? So your impact increases as slope line goes towards y-axis, right?
Mm-hmm.
And of course, right, the values that you have that decides the slope line or the best fit line. We call it as best fit line, right? So
Okay.
once you get the best fit line, each line, okay, has an equation called as mx plus c.
So if the slope is equal to one, are we going to consider it or
No, no,
not?
no. Slope. See, we can't control the slope, right? Data will control the slope, right?
Yeah.
You're
Yeah.
getting a line based on the data set. You can only calculate the slope. I'm just telling you if slope is high, what it means, if slope is less, what it means,
Okay.
right? So, see, slope will come from your past data, supervised learning.
Mm-hmm.
So just hold on, okay? I'm just completing it. So, see, each line has an equation of mx
Mm-hmm.
plus c. Okay, each line has the equation of mx plus c. So in this case, you get y equal to mx plus c. Now, what is m? M is the slope, and c is constant, your intercept. Okay, so this intercept is your c, and this slope is your coefficient. Okay, so sometimes we
Intercept
also call
is the
this as
distance from the
coefficient.
origin. So
Sorry.
intercept is, yeah, intercept
Yes,
is
intercept
equal
is from the
to.
origin.
Okay.
Okay, intercept is from the origin. So this is also called as constant value.
Okay.
Okay, and m is also called as slope or coefficient. Okay, so when you perform your regression analysis, okay, you will get this equation y equal to m x plus c, where m equal to, let's say,
Slope.
1.3 and
Okay.
c is 12. So you get y equal to, let's say, 1.3x, okay, or instead of 1.3x, let me say 9.3x, okay, 9.3x plus 12, okay, you get an equation like this is the line equation. Because see,
Yeah.
once you find the line, then finding the equation of line is very easy.
Mm-hmm.
Okay, equation of line is your m times x plus constant. Okay,
Mm-hmm.
so once you have the line, when you have the line, that means you have slope also and you have constant also. So your equation will be y equal to 9 point. So so this algorithm is going to give us the coefficient and the constant. Now you fill in the x value and you will get the y. So this best fit line is also your prediction line.
Mm-hmm.
Okay. Now if I want to predict, let's say if I study for 10 hours, how much marks I'm going to get? So 10 into 9.3, 93 plus 12. You're almost going to get 100 marks. Okay, if you study 10 hours per day, this is the little relationship. If I study 10 hours per day, I'm definitely going to score more than 90% marks.
Mm-hmm.
Okay, so this is going to give us this mx plus c equation, right?
Yeah.
Okay. So now let's take an example and see whatever we discussed, we'll do with an example. So I have, okay, I'm going to go to Art Studio. I think, can you see my Art Studio? I think I've shared my entire screen, I guess. Yes.
Yeah. Yeah, I can see it now.
Now I have my D data sets, okay, data set, and looks like I may not have it here. Yeah, here I have. Okay, so we'll take this marks data. Okay, and we'll try to see how it works. So I'm going to set this directory as working directory. So I'm going to say set working directory. Okay. Okay. Now when I run it, okay. So I have set this working directory as D dataset. That means when I don't mention the path, if I mention the path, it will take the path which I have mentioned. But if I don't mention the path, it should take by default this path. Okay. So advantage is that I don't have to give the path every time. Now I need to read the data set. So first you set the path and now you read the data set. So data set equal to you have read.csv, okay, and read the file name. So file name is your okay, function, okay, .csv. Okay, you want to see what this data contains? Okay, so you have marks on one axis, sorry, hours on one axis, and marks on other axis. Okay, and we have this data set. That means you have one axis. Okay, this is your input X, and you have output marks. Okay, so now what I'll do is I'll draw a scatter plot. So how to draw a scatter plot? You say scatter dot smooth. Okay. Now first I have to give x-axis. So x-axis is data set dollar. Okay. And what is the okay? I'm not running. So which what should we give as x? Okay. If I read this, it will be easy. Yeah.
X is your number of hours.
Right. Hours. Correct. And then y will be 1. Okay.
Oh, your marks.
Right. Okay. So your okay. Um, so your y is data set. Okay. If you type data set, okay. So now if you draw a plot, okay, if I draw a plot here, okay, okay, now let's run it and see. You see, this is the plot. You see on the right side down,
Yeah, I see it.
right? So this is your now. If you see this, okay, the line that you see is like your best fit line. It is already drawing best fit line for us. We just need to know the the formula for that. Okay, what is the m value? But okay, but keeping that aside, you see, it is we see there is a positive correlation, right? So with positive correlation, it's possible for us to predict marks based on number of hours. Okay, so now to draw this graph, you can also say dot main here, comma, not dot main, comma. Main will give you the headline. So I'm going to say here hours versus Marks update, something like this.
The
Or
title.
studied versus marks. You see, this is the headline that came up. Okay. Okay. Now you see. Tell me what's the purpose of splitting the data set into train set and test set?
To see if the output that we're getting, uh, is right or wrong.
Right.
Yeah.
Okay. So you have limited data set, right? Whatever, 1,000 lines,
Yeah.
10,000 lines, 50,000 lines, you have those data set for training. Now, if you use everything for training, then how will you evaluate the model? How will you know how well your model is working?
Model is working.
Right? So what we do is we say that, okay, I'm not going to use everything for training. I'm going to keep aside 20% of the rows for testing.
Yeah.
Okay. So now we will split data set into training set and test set. So I'm saying split the data set into training set and test set.
Yes.
Okay. So how do you split? So we will say, okay, you have data set, right? So I'm going to say here, okay, training set, okay, training set equal to subset, okay, and then data set comma split equal to, sorry, split equal to true, capital true. Okay. So I'm saying, okay, so take the data set and split it. Okay. And okay, so what is split? Right? We have to define the split. So to define the split, okay, to split basically you have to define how much percentage, right? So I'm going to say split equal to sample dot split. Okay, and I'm going to say data set marks. Okay, and then the split ratio. So I'm going to say data set dollar marks. Okay, and then I'm going to say split ratio. Split ratio. Where is that? It's not coming. Oh, oh, capital. Now, if you want to make it 80%, you say 0.8, right? So
Mhm.
I'm splitting it into 80%. Does it work? No, could not find sample dot split. Yes, could not find sample dot split because we need to import a library called as
Mhm.
CA tools. Okay, CA tools has this sample dot split. So I'm going to say library CA tools.
Mhm.
Now, when you run it, it should work. It is because it is built in older version. Okay, so we need to build it. So how do you build it? You go to packages here,
Mhm.
update. Okay, all packages are up to date. Okay, so I'm going to say install. Okay, install what? CA2.
CA2.
So it's going to update it. Let's download it. Okay. Now, okay. Now you say split worked fine.
Mm-hmm.
See that split worked fine, isn't it? There's no error here.
Mm-hmm.
So when I say split equal to true, that means 80% data should go to training set.
Mm-hmm.
And I will say here, okay,
Just so.
and okay, sorry, what did I do? Test set
Yeah.
data set, here I have to make it false. Okay, so now you have splitted the data into training set and test set. Okay,
Okay.
okay, so data is ready. Now, if you want, you can display, you can print it, obviously, isn't it?
Mm-hmm.
Okay, so data set is ready. Now we are going to run our first model. Okay, so to run first model, and this model regressor is in your CA tools only. Okay, so how do
Mm-hmm.
we first have to create an object? Create regression object. So you say regressor linear regression, linear model. That's what LM stands for.
Mm-hmm.
Okay, so regressor will talk about LM model. LM model takes first formula and then the data set. Okay, so what is the formula? Formula equal to
I'm
your
sorry. LM stands for.
marks. Okay, and then the data that we have is training set.
So, so can you like explain the formula part? Like, what does the sign mean?
Sum.
Okay.
Please sum.
Hello.
Yeah, yeah.
Yeah, yeah. So yeah, can you like explain that thing where it says the formula equal to the
Which
marks?
line? Which
Uh,
line?
I'm sorry.
Which line were you talking about?
On line 11,
Mhm.
uh, where formula equal to like what does that mean? Like marks, the tilted.
Marks tilde hours. Okay.
Yeah.
So formula is the formula that we have to give. Okay, in the sense, how does it know which columns you are using? Okay, so it has
Okay.
two input, formula and data. Data will take the entire data set. Okay, so I'm giving entire training set data set. But
Mm-hmm.
training data set has, in this case, it has marks and hours, right?
Yeah.
So which one is X, which one is Y?
Okay.
So here, the first one that you give in before tilde is your Y. This is
Okay.
treated as Y.
Okay.
And after what you give after tilde is treated as X.
X. Okay.
Okay, so
Okay.
marks tilde hours. Now in later next example we'll see that when we have more than one column, you can say marks plus
Okay.
column 2 plus column 3 plus
Okay.
column 4, so on. You keep adding those extra columns. That is your X basically. But
Okay.
Y will always be 1. So
Always be one.
before tilde, you'll have already have only 1. Now in this
Mm.
case, it's simple because we have only 2, right? So first you have to put your Y value, then you have to put your X value. Okay. So formula equal to the which one you are comparing. So marks versus
Yeah. Yeah.
hours. And from which data set are you getting these column names?
Okay.
Which table basically? Data set is table. Which table are you getting the data? So we are getting it from the training set. So yes, this is going to LM is going to train the model. Train the model means drawing that best fit line. Best fit line, drawing the best fit line is training the model. But now once you get that line, it's so easy to predict. Okay, because you're going to use this line to make prediction. Okay, so you come here and you say summary of regressor. Summary is going to give us the data set. Okay, that is important to understand the output of summary. Okay, so see, this is the output of summary. So call, this is the formula that we gave, right? Residual is the error. Okay, it says minimum residual. Okay, is so if you divide the data set, error, residual is error because when you draw the best fit line, correct? When you draw the best fit line, then the distance between best fit line and point is your residual error, residual.
Okay.
So if you measure all those and put it in increasing order, if you measure all those, let's say if you have 80 such musical, okay, so you have, let's say, like, 80 data point. Okay, so see, let me go to the here, right? So what did I say that you have, this is the best fit line and these are your points, correct? Now, if you take each of these points and put it in the increasing order, okay, so lowest will be, oh, sorry.
Hello.
Can you hear me? Hello?
Yeah, I can hear you.
Sorry, by mistake, I put this.
Yeah, I can hear you.
Yeah. By mistake, I put this
Yeah, that's
Wi-Fi off. Okay. So what this tells you is, okay, now again, let's evaluate. Each of these things is important. Okay. Each of these things is important to understand. This is formula. This is what we called, right? A residual is the error. Error of, okay, so you have best fit line here. This red line is best fit line, correct? Right?
yes.
Now you are finding the distance between each of the points. How many points will be there? Number of point is same as the number of rows, right? Lost?
Yeah, if the point is lying on the line,
No, no.
then it is
Hold on,
still
hold
going
on,
to
hold
do the
on.
calculation.
My question is not that. My question is how many points are there?
Yeah, the number of rows in your data.
Correct. So number of points are number of rows. Okay. Now you are calculating the distance between each of those points and the line. Right? So
Okay.
correct, as you said, some points will be below, right? Like this one. Some points will be above, like this one, and some point will be on the line like this one. Correct?
Yeah.
So now you find the
Yes.
distance between each of the point and each of the line and put it in the increasing order. So first you might have -5, then you might have -4.3, then -3.2, -1.1. Maybe you'll have 0 somewhere, then 0.1, 3, 4, 5, right? These are the values that you will have, right? So it says that if you divide these values into 4 quadrant, first quadrant is median, find the median, then find another median on both the side.
Okay.
You find the median of the entire, first you find the distance between line and the point, each point, put it in the increasing order. So line which are point which are below the line will be negative. You have put them in the increasing order. Now it says, okay, divide this data set into two halves. Fine. Now, each of the halves that we created, again divide into two halves. So finally you will have 4 quarters, right? 4 quarters that we have created. So that's the value
Yeah.
that it's saying. Okay, minimum is the lowest value. Quarter one is the lowest value here. Okay, lowest value here or maximum value this side. Quarter one. Quarter two is this one. Quarter
Okay.
three is this one. And quarter four is the highest value.
Yeah.
So it says,
Yeah.
okay, okay, so it does this. Okay, so minimum value is minus 6.3. That's
Okay.
the minimum
Okay. Got
value
it. Mm-hmm.
of a point to the line. Okay,
Yeah.
or you can say uh, farthest point below the line. See, minus, when
Yeah.
you increase the minus, so minus is just the direction, but actual value is 10, right? 10 in the lower direction. So that will tell you
Mm-hmm.
that's the point which is farthest from the line below the line. And on the extreme right value that you get, the line from, you know, um, uh, so this is like the point which is farthest away from the line, but on above the line. That's why you get positive.
Yeah.
Okay. So the entire data set you break into 4 parts, you get 4 values.
So for like minus 3.7, so it is, I mean, it is the minimum in the second quadrant, Q2, right?
Uh, Q1, right? This is Q1, correct? Q2 is same as
Yeah. So
median.
Q2, okay.
Same as median.
So the minimum is the least value in the Q1, and minus 3.7305 is the maximum value in Q1.
Maximum value in Q1. Okay, yes.
Yes, okay.
Right.
Yeah, and the median.
Yes.
Um,
Okay.
okay, got it.
So this is the lowest value. Okay, this is the lowest value. This is the highest value. This is the midpoint. And this is the left side midpoint. This is the right side midpoint.
Also, fine. Okay.
So now if median is minus, that means it has more values below the line. That's what it indicates. Okay.
Mhm.
At least this is just to understand the data set. Okay. This is not something
Yeah,
which
yeah.
is important for learning the model. But yes, it tells you that most of the values are below the line. That's why you're getting median also as median ideally should be 0. That means
Zero.
equal number
Okay.
of above, equal number of below. But it doesn't
Okay.
happen, right? So
Yeah.
minus means you have still more values on negative side than the positive side. That is above the line.
Yeah.
Okay. Now, this is what is important for us. Okay. This is important. This is what we
Coefficient.
look for. This is what we are running this model called coefficient. I told you, right? So
Yeah.
the equation is given by coefficient plus. So here in this example, okay, the answer that we are going to get is
So
y
for the
equal.
coefficient,
Sorry,
I'm sorry. Sorry. So the coefficients is the distance from the origin.
that is the intercept. This one, 20.7.
Yeah, the intercept.
Yes.
So I see like 1.8. What is all that like
I'll tell you.
estimated?
I'll tell you. Hold on. We'll go step by step. Okay.
Okay.
We'll go step by step. So first, let's focus on the estimate only. Okay. Then we'll go to here. Estimate
Okay.
tells you estimate of intercept is 20.575. Let's say 76. Okay. So I'm going to say 20.76 plus. Okay. Plus what? Estimate hours is this. Okay. So this is your slope also. This is your intercept, and this is coefficient of hours or slope, right? So mx, right? So mx is m is 7.5 0.57. Okay, x. Let's see. So this is the equation that you are going to form.
C is the constant. M
Constant
is
or intercept?
okay. M is the. I'm sorry. What was it?
So yeah, I didn't understand the question. What are the question here?
Yeah, yeah. So I understood C.
Right?
So like M is. I'm sorry. What was M?
M is slope or coefficient.
Okay. Okay. Got
Hours. Hours, you see, it is the coefficient of hours. See, here you have only one x, right? Next
Mm-hmm.
example that we'll see, we'll have more than one x. So
Okay.
you will see all of them there.
Okay.
Okay. So now tell me, if I study for 4 hours, how much marks will I get?
Yeah, we should do the calculation. 7.5 into 4 plus 20.76.
Right? 7.5 into 4, which is 60 plus 20, or 80 something,
Mm-hmm.
right? So see, you are now able to predict it. You can predict future now.
Yeah.
Okay. So we just now built our first model. Okay. Now you can predict the future, isn't it?
Mm-hmm.
Yes. Now what does other values mean? Okay. So see, it is obviously it is not absolutely what you call perfect value. There will be some error. So what it says is it is 20.7 plus or minus 1.8. That's the error that you are representing. Now you're not talking about the exact value. See, when you talk about futuristic thing, right? You cannot be sure that it has to be 50.9 only.
Yeah.
Correct? It's not that accurate. But if it is about past, yes, okay, you will easily get the answer. But when you talk about future, it says, okay, and that's why, so, so when we talk about something future, we are not very sure that, oh, it will be 50.999. No, we say that it will be between 45 and 55,
Mm-hmm.
around 50. That's what we say. Around 50 is what I expect. So
Mm-hmm.
around is, that is what this is tells you. Error. Standard error is plus or minus.
Mm-hmm.
So there is a plus or minus error for intercept. So intercept is to 20.7 exact, but it could be anywhere between 18.7 to 23 something. Okay, minus and plus 1.8. And hours can go plus or minus zero point 0.3. Zero point 0.3 means very low, right? I mean, almost no change in decimal.
Mm-hmm.
So that's the equation, that's the coefficient of your intercept. So you get, and then you, that's the error that you can expect. Okay, plus or minus, that is the standard error. Okay, next you see that's the t value. Okay, now t value, okay, is the t is the statistics. Okay, it's the test to see how well your data, okay, is able to
Predict.
predict, okay, or connect with the data set that you have worked with.
Okay.
Okay, the data that we got from here, right? From training set, how well we have worked. Okay, so T tells you your effort. Now, P value tells you how confident you are.
Mm-hmm.
Okay, P value, we want it to be zero, okay, close to zero. Okay, then you say that we accept the result. That means this you asked me, right? How do you know? Okay, how do you know if that feature is important, right? I told you I'll tell you later, isn't it?
Mm-hmm.
This value will tell you how important is the feature.
Okay.
Okay. So first thing is you can look at the star.
Mm-hmm.
Okay. If you have 3 star, 2 star, or 1 star, okay, maybe even okay. So if you have this kind of star, if you have star, that means it is relevant.
Relevant data.
Okay. So how do you get the p value has to be very close to zero basically.
Mm-hmm.
P value should be closer to zero. Okay. A p-value has a probability association. Okay,
Mm-hmm.
1 minus p is a probability. So if p is 0, okay, which will never be okay equal to 0, it will be 0.00000001. Okay, that means, okay, it means that opposite of, so if p is 0, that means you're 100% sure that you are that that feature is actually impacting your analysis very well.
Mm-hmm.
If you see, there's a 3 star against intercept and hours both. So either you look at the value or you look at the star. So here it tells you, okay, it's called significant. P value is also significant code. So if it is 0 to 0.001, we generally give 3 stars. If it is 0.001 to 0.01, okay, it means 2 stars. 0.01 means 99.9%.
Mm-hmm.
Makes sense?
Yeah.
If you see no star, right? If you
Mm-hmm.
say no star, that means that feature is not important and we have to remove it.
Okay.
Even if you see 1 star, you will accept it.
Okay.
All right.
Yeah.
So if you see there is no star, that means that feature does not have impact on your Y value, and you can statistically remove it. Okay.
Mm-hmm.
So one more thing we read here is that always experience takes higher precedence than your statistics. Yes, statistics says that you need to have at least 1 star. Your p-value has to be more or less than, sorry, p-value has to be less than 0.05.
Mm-hmm.
P-value has to be less than 0.05. That means you are more than 0.05 means 95% confident. You are
Yeah.
95% confident. That's what 0.05 means. So your confidence level has to be more than 95% in order to accept. Otherwise, you reject. So
Okay.
if you see a star, even one single star, that means those columns are accepted and you should include them in the final prediction.
Okay.
Okay. So
Okay.
that's how the significant code is important. And to answer the question, yes, that star will tell us should we accept the feature or not.
Yeah.
Okay. Now, uh, okay, one metric to measure is your R squared value. Okay, R square and adjusted R square. Adjusted R square is important. It's calculated based on if you have a more than one x, right? So mostly when you will have definitely more than one x, so you should be using adjusted R square. But if you're talking about only one metric, okay, it has to be, okay, your R squared value. R
Okay.
squared value ranges from 0 to 1. Maximum is 1. That means your model is doing very good.
Mm-hmm.
0 is
Not doing good.
yes. Okay. So you have, so now you know what is um, R square. Okay. So this is what will dictate how well your model has. This is the evaluation criteria.
Okay.
Have you done overfitting, underfitting?
No.
Okay. Tomorrow we'll do. Okay. So I'll tell you how to look at this criteria and what it means. Okay. So tomorrow I'm going to tell you. Now, so this is
The data.
adjusted. Yeah. Sorry.
So, so using the test set to determine if this is so. Oh, so I mean, it already did the comparison and then gave us these values.
Exactly. Exactly.
Okay. Okay.
Okay. So summary will give you all the values together. Okay.
Okay.
So
So it's
summary,
comparing the result with the test data.
yes.
Okay.
And based on this, we make our report or our understanding. Okay. So you have both I mean, not both. You have the this dashboard. Okay, which tells you the story. Now this tells you 4.59 is overall residual error. Okay, on 28 degrees. Now, 28 degrees of freedom, okay, means how many uh, how many rows you have, okay? Rows minus number of columns. So you have 30 rows minus 2 columns, so it becomes 28. Degree of freedom is 28.
Mhm.
Okay, but as I said, right, what is important is this table. Okay, this table is important. This tells you what should the equation be. This will tell you what should the p value be. Okay, and what happens if p is more than 0.5.
Okay.
Okay, so shall we stop here today?
Yeah.
So tomorrow when we meet, we'll talk about the model evaluation. So we have seen how to do the pre-processing, get it ready for the model. Running model will be like this only. Okay,
Okay.
running model is the simplest thing. Okay, so don't worry about model. Okay, but what do you do after you run the model is important. Okay,
Mhm.
parameter thing. So when you see, there are okay. So when you run the algorithm, machine learning algorithms, at a high level, you are thinking about three things. While while solving this.
So I have a question. So we're building this in like R, right? How will I mean how
One second,
how
one second, one second. I'll just finish off this. Okay,
sure.
just give me 1 second. Just hold on a question, right? Okay. I think I don't know why today I'm finding it little difficult to hear, right? Volume is looks seems to be low. So
I'm using another laptop. Maybe that's the reason. From tomorrow I'll use the other one.
okay. So I have to really concentrate on your voice to actually I hear your voice, but it's not very clear.
Clear?
Like low
Okay.
volume kind of thing.
Okay.
Yes, tell me, no?
Yeah, and so I have a question. Like so we're doing like the machine learning in here, like in our studio, right? So how is this? I mean, is this related to like using this in tools?
Yeah,
I
yeah,
mean,
yeah, yeah, yeah.
especially machine
This is your
learning,
R code,
Tableau.
right? This is the R code, and this is what you will use. See, you need a tool, right? Okay. So
No, no. So when I say tool, I mean Tableau or like Power BI. Um, so how will we? I mean, how will we like use this concept in there, or is it something completely that you do only in our studio?
this is something that you completely need to do in R. Okay. R studio is
Okay.
again a tool, right? Okay.
Mm-hmm.
But this running the model that you are doing, LM model, right? For example, LM you did, for example,
Yeah.
said we did. These are
Mm-hmm.
available only in R.
R. Okay.
Okay. So what we do is you save this script as .r file and you can run it on any R. So R Studio is only a editor basically. Okay.
Okay.
R Studio is only an editor. Okay. It could be Notepad also. You can do it in Notepad also. Okay. But to
Okay.
execute it, you need R. So this is not your Power BI thing.
Okay.
But what you can do is you can run all this, save this information in a CSV file, and
Okay.
that CSV file you can pull it using Power BI and you can show.
Okay.
Right? For example, the chart that we drew, right? You can
Mm-hmm.
directly use you can directly read CSV file in Power BI and run.
Okay.
But running the model, it has to be done in R. You cannot use Power BI to run the model.
Okay.
So you run the Power BI, do all the calculations and then save it in a CSV file so that which can be picked by your Power BI.
Okay.
Okay. Okay. So I was talking about while solving business learning problem. Okay, where do we spend time? Okay. So we spend time at three places. One is my data in a ready state to run the algorithm. Okay. Next is run the algorithm and check the values. Now, when you check the values, okay, then let's go to third one then. Evaluate the performance of the algorithm. Okay. Now, coming back to second. So, when you're running this model, right, to you have to see that is this the best model? That means, can I improve this model? Okay. Second question is, okay. Second question is, no. I combined the both the two. Okay. Is this the best model? Okay. And is this the best performance of this model? Okay. So is this the best can this algorithm give me more better result? Okay.
Okay.
In linear regression, you don't have anything. Okay, you get only one answer, right? So there's nothing that you can do much. But when you talk about SVM and decision tree, there's some parameters that we need to pass.
Mm-hmm.
Okay, and you keep changing the parameter until you figure out that this is the best model. And we'll talk about what is the how to find out the best model. Okay, so this is first. Let's say you chose SVM. So what is the best performance, optimal performance of SVM? Right? If you take random number, random parameter, you get random answer. That doesn't
Mm-hmm.
mean that SVM is that bad. You need to select right set of values to run your model. So those models, those when we run those models, they will also need some parameters.
Mm-hmm.
Okay, so some parameters that need to pass, and we'll talk about those parameters when we talk about those examples. But in this case, in linear regression and simple and multiple that we're going to do, there is no way you can look at the parameters. So whatever you get, this is the answer. Okay.
Okay.
So here, second question to A is this the best out of the model? Answer is yes. Because here there is nothing you can do. Huh. Let's say if you had 4, 5 and there was some with none, right? No star. Then we need to
Mm-hmm.
remove that feature. You asked me, right, how to analyze? So then
Yeah.
you need to remove that feature. Then you don't get best answer in the same step. Remove
Mm-hmm.
the feature and then again you run. Right? Now, what is the best answer, best
Yeah.
performance is dictated by R square.
Mm-hmm.
So here you have something called as RMSE and R square, and we're talking only as R square for now. R square value range from 0 to 1.
Mm-hmm.
Okay, closer to 1 means best performance. Okay, so is this the best model? So you run 2, 3 model. The model that gives you R square, highest R square, that is your best model.
Mm-hmm.
So how do you evaluate? Same model with multi parameters, a different model is finding out R square. Higher the R square, better is your model. Now, what is R square? R square is a metric that measures how well your algorithm has performed with respect to basic value or average value.
Mm-hmm. Okay.
Got it?
Hello. Yeah.
Okay, so R square closer to 1 means is the best model. Okay, now and the trick here is not always. Okay, not always. Sometimes, okay, so what I'm saying is the student that gets the highest mark is the best student.
Mm-hmm.
So statement makes true sense, but not always. What if the student has mugged up all the answer and has got full marks?
Yeah.
If student has marked up and got the full marks, then you cannot say that, the student who got the maximum marks is the
Is
best
the best student.
student, right? So what we need to do is we need to see. So this is based on uh, summary regressor. This is based on training data. So we need to perform what we need to perform both training performance versus test performance. Okay. So we enter into what is called as overfitting and underfitting. We'll talk about it tomorrow. So
Okay.
so two things that we need to talk about tomorrow is, of course, overfitting and underfitting, and we'll take a multi-linear algorithm so that we'll have more columns, and we'll see what happens to this value, p value.
P. Okay. Yeah.
Okay, and we will learn to select.
Okay.
Okay, hopefully tomorrow we will be able to wrap up uh, uh, multiple linear and the evaluation. So once you understand evaluation, then rest of the algorithm is just about talking, telling you what it means. The main thing is making
Okay.
data ready. Second thing is, running and executing your model to get the best value. That's what we are doing right now. And then we have to evaluate the
Mhm.
model. How well you evaluate model has evaluated, has performed. So R square.
No.
R square in a way is a way you compare um, your regression performance with respect to average line. See, before regression,
Mhm.
okay, when we didn't know regression, what we used to do, we used to take average. Now, we look at average marks scored by student of a school, right? So, if you want to evaluate, let's
Mhm.
say you want to select three schools, okay, you have to, option of selecting three schools, and which school will you select? So, for now, let's say your criteria is just the high marks. So, what you'll do, you will take
Mhm.
average of marks obtained by all the students.
Average of fine. Yeah.
And
Yeah.
then you say, oh, average marks scored by this school is higher, so we'll go. No. So now what we're doing is, since we know regression, we say that, okay, no, it's not about school performance. It's also about the student performance, right?
Mhm.
I want to see how well student is behaving and how much marks they're getting. So
Mhm.
now you're not talking about every student of that school. You're talking about student who studies 3 hours in 3 hours at home, okay, and that student is common across all the three school, and then you ask, you see who's getting more marks. Okay, if
Okay.
student who's not studying getting higher marks, that school is probably better than other school, right? So you don't look
Mhm.
at just the
Yeah.
average marks of the school, but you're going down to each marks, each student. That's what we are doing here. We're going to each marks, each student here.
Mhm.
Okay, so this is the difference between your average when you were not knowing regression versus now that you know regression.
Yeah.
Regression says no, we have to classify, we have to group. Do not consider all the data as one. R square does that.
Mhm.
R square compares how well your. I'll show you the formula. Okay, it's there in that book. I'll show you towards the end when you are doing it. Shows you, okay, how well,
Okay.
okay, your model has performed with respect to average. So
Mhm.
let's say in this example, okay, so this is your regression line. I will draw one. I'll take average. I'll draw one more line, average line.
Yeah.
So so when I say performance, now I'll find the distance between point and this average line versus the distance of this point with the regression line.
Mhm.
Obviously, the regression line will have a better result. Let's this thing. So your average, actually the formula is 1 minus your error in regression by error in total.
Mhm.
Okay, average. Basically, it's average. So what happens? This distance will be more, isn't it?
Yeah.
This value will be more because we're talking about total. Total will be higher than the regression. See, the definition of regression line is the best fit line, correct?
Mhm.
So there cannot be any line which is better than the regression line or the best fit line.
Mhm.
So numerator will be smaller, denominator will be greater. So this value will be less than 1. 1 minus less than 1 will be something less than 1 only, right?
Yeah.
Now, answer the best case is where your average value is very high, but your regression value is almost 0. Okay. So this you get 0. 0 by anything is 0. 1 minus 0 is 1. So best case is when your R square is 1 or tends to become 1. That's the best case.
Okay.
Okay, that's why we say R square. Okay, R square is a criteria which will help us to measure how well you have predicted uh, and we predicted with respect to the average line. Okay,
Mhm.
closer to 0 means it's the zero error. I mean, 0 means zero error, which is really not possible. So we are saying
Mhm.
very close to 0, your model is worst. Very close to 1, your model is best. The higher the
Very
R
good.
square value, better it is.
Yeah.
Okay. So yes. So
Okay.
we'll take another example tomorrow, and we'll repeat some of these concepts again tomorrow.
Okay.
Okay.